Hey everyone, and welcome back to the deep dive. Today we're diving into the world of large language models.
LLMs.
LLMs, yeah.
Yeah.
Those AI systems are making so much noise. We're going to be focusing on a paper today, specifically for all you Kagglers out there.
It's called
Yeah.
Foundational Large Language Models and Text Generation.
So, get ready, folks.
Yeah.
We're going to see just how these things work.
We're talking AI that can, write code, translate languages,
Yeah.
solve really, really tough math problems.
It's crazy.
It's really a wild ride how we got from their humble beginnings to today's, absolute superstars.
Like Gemini. I got to ask, how do we get from these, simple language tools to AI that's practically writing symphonies? That's a huge jump.
Well, it all starts with this idea that language models are basically just predicting what word comes next in a sentence.
Okay.
Sounds simple, right?
Right.
But that's the bedrock of everything that they do.
Yeah.
From translating, languages to writing code, it's all about understanding these relationships between words.
Okay, that makes sense. But how did they get so smart? Didn't they used to be, like, way slower and, less capable?
Yeah, so you're thinking of the old RNNs,
Mhm.
recurrent neural networks.
Right.
They were kind of like reading a book, like one word at a time, Which is fine for short stuff, but
Yeah.
really slow for big chunks of text.
Right.
And then came transformers, and they
Right.
completely, changed the game.
Okay.
Transformers are like reading a whole paragraph at once,
Right.
and just grasping the meaning instantly.
Interesting.
It's all thanks to this thing called the self-attention mechanism.
Transformers, self-attention.
Yeah.
These names are kind of sci-fi, not gonna lie.
They are a little bit.
Yeah.
Yeah, they are.
Can you break it down for us? What is this? What is self-attention?
So imagine you're at a noisy party and you're trying to follow like 3 different conversations at the same time.
Oh, been there.
Yeah, exactly. And your brain is focusing on different parts of each chat to kind of get the gist, right?
Right.
That's basically what self-attention does for a transformer.
Okay.
It zeroes in on, the most important parts of whatever input it's getting.
Okay, I'm starting to get it. But this self-attention, does it really work like our brains? That seems kind of, far-fetched.
Yeah, so let's test it out, right?
Okay.
Take the sentence. The tiger jumped out of a tree to get a drink because it was thirsty.
Okay, a thirsty tiger. Got it.
Yeah, and we instantly know that it refers to the tiger.
Right, not the tree.
Not the tree, yeah. So self-attention helps the model to make that same connection,
Oh,
just like we do.
interesting.
Yeah.
Okay, so the text is prepped. The attention mechanism is doing its thing.
Yeah.
What else is going on inside this transformer? What makes it tick?
So think of it like a really high-tech factory
Okay.
with different stations.
Right.
Right. And first, you've got to prep the text. Kind of like ingredients for a really complicated recipe. So this involves tokenization,
Right.
like breaking down the text into bite-sized chunks,
Wow.
and then embedding, which is turning those chunks into numerical representations that the model can understand.
Yeah.
And then finally, positional encoding.
Okay.
So the model doesn't forget the order of those chunks
Sure.
because sequence matters.
It does. All right, so our recipe is ready. Now what?
Right.
Time to cook up some AI magic.
Yeah, now this is where the multi-head attention mechanism steps in. It's really like the heart of the transformer,
Okay.
where it's analyzing these relationships between words in a sentence, right?
Mm-hmm.
Kind of like figuring out which words are related to each other. It's how the model gets context
Okay.
and understands meaning.
So it's kind of like a detective piecing together clues, right?
Yeah, absolutely.
Okay. But we've been talking about processing text. How does a transformer actually learn from it?
Okay, so that's where training comes in. Imagine like teaching a kid to read. You give them books, they try to read, you correct them, they learn.
Right.
It's similar with transformers, except they devour like mountains of digital text.
Right. So we're talking massive digital libraries, right?
Oh, yeah.
But what's happening behind the scenes during this training process? Is it just reading and memorizing?
It's more like a feedback loop.
Okay.
We feed the model batches of text. It tries to predict what comes next.
Uh-huh.
We check its answers.
Right.
And based on how well it does, the model tweaks its internal settings,
Okay.
kind of its parameters, to
Right.
get better at predicting. So it's constantly kind of learning and improving.
That's so cool. But how do these different transformer architectures like GPT and BERT, change the learning game? Are they all trained the same way?
That is a great question. They actually all have kind of their own learning style tailored to their strengths. So think of GPT, the decoder-only model, kind of like a storyteller. Its training, it's really focused on predicting the next word in a sentence,
Right.
kind of trying to like finish your story for you.
Okay, so GPT is like a novelist.
Exactly.
Got it. What about BERT, the encoder-only model?
BERT's more like a puzzle master.
Ooh, okay.
It's trained to fill in missing words
Uh-huh.
or guess the next sentence.
Right.
And it really excels at understanding the context and relationships between words.
Got it. So different learning styles for different tasks.
Exactly.
That makes sense. Speaking of different models, we've seen so many LLMs pop up in the last few years. It's like a whole family tree of AI. Can we trace this evolution from like GPT-1 to the latest and greatest like Gemini?
Absolutely. So let's start with, GPT-1, the OG. Right. One of its biggest breakthroughs was unsupervised pre-training.
All right.
This meant that the model could learn from tons of unlabeled text, basically teaching itself.
So it's kind of like learning a language by immersing yourself in it, right? No
Yeah.
textbooks, just pure exposure.
Exactly, yeah.
Got it. What about its successor,
Yeah.
GPT-2? How did it up the ante?
So GPT-2 went big.
Okay.
It was trained on a data set 10 times larger than GPT-1
Wow.
and had 10 times the number of parameters.
Okay.
It was like giving the model a supersized brain
Okay.
and a whole universe of text to learn from.
Wow. Talk about a growth spurt. What kind of impact did that have on its ability?
Oh, it was mind-blowing. So GPT-2 could generate super realistic
Uh-huh.
and coherent text, mimicking human writing styles,
Oh, wait.
like with scary accuracy.
Wow.
Yeah. It was like the model had absorbed all of this knowledge
Yeah.
and could now express itself really eloquently.
So it went from like babbling to writing poetry, basically.
Exactly. Yeah.
Wow. And then came GPT-3, which made even bigger waves. What were the game changers with GPT-3?
So GPT-3 just kept the scaling trend going with a mind-boggling 175 billion parameters.
175 billion. Wow.
Yeah. But it also brought something new to the table, few-shot learning. So it could understand and perform tasks with just a few examples.
Oh, wow.
Yeah.
So no need for those, like mountains of labeled data.
Exactly. Yeah.
That's incredible. It's like learning a new skill just by watching like a quick demo or something.
Yeah.
So efficient.
Yeah.
What about GPT 3.5 and 4? How did they build on this foundation?
So they really doubled down on dialogue
Okay.
and added multimodal understanding,
Okay.
which means that GPT-4 can actually handle images and text.
Wow.
Yeah, which is a huge step forward.
Huge.
And they also expanded that context window
Right.
so they can remember longer conversations or documents.
Okay, GPT's evolution is super impressive.
It is.
But Google's been in the game too, right?
Oh, yeah.
What about their models? Tell me about LaMDA.
LaMDA, yeah. Language model for dialogue applications. Google's answer to that conversational AI challenge.
Right.
Right? So, while, GPT models are kind of like these multi-talented performers, LaMDA is like the smooth talker, specializing in really natural, engaging conversations.
So it's all about making that AI chat, feel more human, less robotic.
Exactly.
I love that. What about Gopher, DeepMind's contribution to the LM party?
Yeah, so Gopher was all about refining that training process. They were super meticulous about data quality and optimization.
Okay.
Yeah, creating a model that's just a beast at knowledge-intensive tasks.
So it's not just about like how MECH data you feed it,
Right.
but also the quality and how you actually train it.
Exactly.
That's interesting. And speaking of training, wasn't there a model, Chinchilla, that kind of changed our thinking about scaling?
Oh, yeah. Chinchilla, yeah, they really challenged the, bigger is always better mentality.
Right.
Their research showed that scaling data and parameters equally is crucial for optimal performance.
Oh, interesting.
So, you can have smaller, more efficient models that still pack a punch.
That's a game changer. Efficiency matters. Google must have taken note of that with Paul M., right?
Yeah.
Their model is a bit of a behemoth, isn't it?
Paul M., the Pathways language model, is definitely a heavy hitter with 540 billion parameters.
540. Goodness.
Trained on a massive data set of text and code.
Wow.
And it can really tackle everything from common sense reasoning to really complex code generation.
Paul M sounds like a real powerhouse. What about Paul M2? Did they make it even bigger?
Actually, they focused on making it smarter.
Okay.
Paul M2 has even better reasoning abilities and excels at things like code generation and complex math problems.
Right.
And they actually did it with fewer parameters than Paul M, so talk about efficiency.
Wow, it's amazing how these models are getting smarter, A&D more efficient.
It is.
But there's one more I'm dying to hear about, the superstar of Google's LLM family, Gemini.
Gemini, yeah. Gemini is the real deal. It really combines the best of all of the previous models
Okay.
and takes that multimodal understanding, to the next level. We're talking text, images, audio, video, all processed seamlessly. It's like the ultimate AI Swiss Army knife.
Okay. That's officially mind-blowing. And with Gemini 1.5, they've expanded the context window to, like, millions of tokens.
Yeah.
That's insane.
It's like, having an AI with a photographic memory.
Right.
It can process and recall information from massive amounts of data.
Wow.
Connecting the dots, drawing inferences across, like, entire books.
Wow.
Even movies.
So it's not just about understanding these little pieces of information.
Right.
It's about putting it all together.
Yeah.
And making sense of the big picture.
Exactly.
That's wild.
Yeah.
But all this power, all these capabilities seem like pretty inaccessible for most people.
Right.
Is Google trying to change that?
They are. With Gemini Nano, they're actually bringing powerful AI capabilities to, smaller devices like smartphones and wearables.
Okay.
It's a testament to how fast this technology is evolving and becoming more accessible.
It's exciting to see LLMs moving beyond those research labs and into our everyday lives.
Yeah.
But it's not just Google making moves in open source LLMs. We've seen other players like Meta and Mistral AI step up to the plate, right?
Oh, absolutely. The open source LLM scene is booming. Models like Llamo from Meta and Mixtral from Mistral AI are giving, researchers and developers really powerful tools to explore these, frontiers of AI.
It's amazing to see this level of collaboration and innovation,
Yeah.
It's like the whole AI community is working together to unlock the full potential of LLMs.
Exactly. And with xAI's release of Grok 1, we're seeing even more ambitious models going open source.
Wow.
Right? So making these powerful capabilities available to everyone.
It's a golden age for AI development.
Yeah.
It's incredible to see how far we've come from those early days of transformers to these sophisticated multimodal LLMs.
Right.
But it's not just about building bigger and better models, is it? We need to learn how to fine-tune them for specific tasks and truly unleash their potential.
Exactly. You're spot on. That's where fine-tuning comes in. It's how we take these general-purpose language models and turn them into specialized tools that excel at specific jobs.
All right. I'm all ears. Let's dive into this world of fine-tuning and see how we can mold these powerful LLMs into, like, precision instruments.
Yeah. It's like taking, a raw diamond and cutting it just right to unleash its brilliance.
I love that analogy.
We'll explore techniques like, supervised fine-tuning, reinforcement learning from human feedback, and parameter-efficient fine-tuning, all designed to make these LLMs more effective and aligned with our goals. Let's kick things off with supervised fine-tuning.
Okay.
Or SFT for short.
SFT.
It's like sending our LLM to a specialized training program, to become an expert in a specific area.
So instead of being a jack of all trades, it becomes a master of one.
Exactly.
I like it. How do we make that happen?
So we give it a crash course, using a smaller, carefully curated data set that's specifically designed for that task.
Right.
So for instance, if we want our LLM to be a whiz at summarizing research papers, we'd train it on a data set of papers and their corresponding summaries written by humans.
So it's learning from the best, the expert summarizers.
Exactly, yeah.
Okay. Once our LLM has aced SFT, what's the next step in this fine-tuning boot camp?
Right, so that's where reinforcement learning from human feedback comes in.
Okay.
RLHF, for those who like acronyms.
RLHF, okay. That sounds intense. Is it like a personal trainer for our LLM?
Exactly.
Pushing it to reach its full potential?
Yeah. So in RLHF, we actually use human feedback to train a reward model.
Okay.
This reward model acts like a judge, learning to tell the difference between
good and bad
responses from the LLM.
Got it. So it's like a talent show. the LLM is performing, and the reward model is giving it scores
Yeah,
based on the judge's preferences.
exactly.
I love that analogy.
And this feedback then helps us to, fine-tune the LLM even more,
Right.
encouraging it to generate responses that really hit the mark.
It's like the LLM is constantly trying to impress the judges, get a standing ovation.
Yeah.
That's such a cool concept. But you also mentioned something called parameter-efficient fine-tuning,
Right.
or PEFT. What's that all about?
Yeah, so PEFT tackles a real-world problem, Fine-tuning these massive LLMs can be computationally, really expensive.
Right.
Imagine having to retrain a model with, billions of parameters just to teach it a new trick.
Right.
PFT offers a much more efficient way.
So instead of retraining the whole model, we can focus on fine-tuning specific parts.
Exactly.
Right. That sounds a lot less daunting.
Yeah. So PEFT techniques like adapters and LoRa let us add these small, specialized modules to the LLM without messing with its kind of core structure.
Got it. So it's like adding a few specialized tools to our LLM's toolbox.
Right.
Instead of rebuilding the entire workshop.
Exactly.
Very clever. So we've fine-tuned our LLM. It's ready to go.
Yeah.
But how do we actually use it? How do we talk to it? Tell it what to do?
Right. So that's where the art of prompt engineering comes in.
Prompt engineering.
Okay. Yeah. It's all about crafting these effective instructions, the prompts, to guide the LLM and get the results we want.
So it's like giving our LLM a clear recipe.
Yeah.
With step-by-step instruction.
Yeah.
To create the perfect dish.
Precisely. So the way we phrase our prompts can make a world of difference.
Interesting.
A well-crafted prompt can actually nudge the LLM to generate more accurate, more relevant, and more creative outputs.
So it's not just about what we ask, but how do we ask it?
Exactly.
Are there different types of prompts that we can use to get different results?
Yeah, there are a few tricks of the trade.
Okay, let's hear them.
So we have zero-shot prompting, where we just give the LLM a task description and let it use its existing knowledge to come up with the response. Then there's few-shot prompting, where we give it a few examples to kind of steer it in the right direction.
Got it.
And finally, there's chain of thought prompting,
where
we actually walk the LLM through how to solve similar problems, step by step.
It's like we're teaching it to think like a detective.
Yeah.
Breaking down the problem, following the clues.
Exactly.
Yeah. Okay, but once we've given the LLM a prompt, how does it actually choose what to say?
Right, so that's where sampling techniques come in.
Sampling techniques, all right.
And they control how the LLM picks the next word in a sequence, kind of influencing the style and the variety of its output.
So it's like choosing the right words to paint a picture.
Yeah.
Some techniques create a realistic image.
Right. Others go for a more abstract style.
Exactly. So we have techniques like greedy search, always picking the most likely word, which leads to predictable, but, kind of safe outputs.
Safe. Got it.
Then there's random sampling, throwing some unpredictability into the mix.
Right.
And then techniques like temperature sampling and top case sampling allow us to kind of fine-tune that balance between predictability and creativity.
It's fascinating how we can guide the LLM's creative process.
Yeah, it is.
But let's talk about something a little bit more practical. As these LLMs get bigger and smarter, actually getting responses from them, the inference part, seems like it could take forever.
Yeah, you're absolutely right. As LLMs grow, the computing power and memory they need just explodes.
Right.
And this can lead to, longer wait times and higher costs, which isn't ideal for real-world applications. Right. So how do we deal with that? How do we speed things up and make these powerful models more accessible for everyone?
Right. So that's where inference optimization techniques come in. And researchers and engineers are constantly finding these clever ways to make inference faster, cheaper, and more practical.
That sounds promising.
Yeah.
Can you give us a sneak peek into some of these techniques?
Yeah. So one approach is quantization.
Quantization.
Just like streamlining the model's internal calculations without sacrificing too much accuracy. So by using lower precision numbers, we reduce the memory footprint and speed things up.
So it's like using shorthand to make the calculations quicker without losing the meaning.
Exactly.
That's clever. Are there other ways to make LLMs more efficient?
Yeah, another technique is distillation.
Distillation,
where we train a smaller, faster student model to mimic the behavior of a larger teacher model. So it's like, passing on the wisdom of a master to a promising apprentice.
Oh, I like that. So the student model learns the tricks of the trade
Right.
from the expert
Yeah,
and can then perform the task more efficiently.
exactly.
That's really cool. What other techniques are out there?
So there are also output preserving methods,
Output preserving. Okay.
which guarantee that the model's response remains unchanged.
Unchanged. Okay.
One example is flash attention.
Okay.
And it's a way to optimize like a core part of the transformer,
Okay.
the attention calculation, without affecting that final output.
So it's like fine-tuning the engine of a car
Yeah.
to make it more fuel efficient
Right.
without changing how the car drives.
Exactly.
That's impressive. What about prefix caching? What does that do?
Yeah, so prefix caching is super helpful for things like chatbots
Wow.
or, when you're analyzing long documents.
Right.
It lets us store and reuse previous calculations for
Yeah.
parts of the input that haven't changed,
Right.
Saving time and resources.
It's like remembering the answers to questions we've already asked
Yeah.
instead of having to figure them out again and again.
Exactly. Yeah.
Smart. What about speculative decoding? How does that speed up inference?
So speculative decoding is a bit like having a team of assistants working in parallel.
Okay.
It uses a smaller, faster draft model
Right.
to predict multiple tokens ahead,
Okay.
which the main model then double checks.
So it's like brainstorming ideas,
Yeah.
generating multiple possibilities,
Oh.
and then having the expert pick the best one.
Exactly.
I like that.
Yeah.
With all these optimization tricks, it sounds like LLMs are becoming more practical by the day.
They are.
Now, I'm even more curious about how they're actually being used in the real world.
Yeah.
What are some of the most exciting applications out there?
So LLMs are already making, a huge impact in so many areas,
Right.
from code generation to machine translation, text summarization,
Right.
question answering, and even creative content generation.
Wow.
It's like having this superpower assistant for almost every task imaginable.
That's amazing. I'm especially interested in how LLMs are, shaking things up in the world of code and mathematics.
Yeah.
Are they really becoming these valuable partners for developers and mathematicians?
Absolutely. In the realm of code, LLMs are revolutionizing things like code generation,
Right.
completion, refactoring,
Wow.
debugging, and even like translating between programming languages.
Wow.
Yeah.
It's like having an AI pair programmer
Yeah, exactly.
who can anticipate your next move
Yeah.
and help you write better code faster.
Absolutely.
And what about math? How are LLMs making their mark there?
So they're showing incredible talent in tackling these complex math problems.
Okay.
From, basic arithmetic to advanced concepts and abstract algebra
Wow.
and geometry.
That's crazy.
These models are going beyond just manipulating language. They're actually reasoning about abstract mathematical concepts.
It's like having an AI mathematician on your team.
Yeah.
Helping you solve those, tricky equations.
Absolutely.
That's mind-blowing. And beyond code and math, LLMs are also changing the way we translate languages.
Yeah.
Are we getting closer to that universal translator we've always dreamed of?
We are, we're getting closer than ever.
Right.
LLMs are making translations more fluent, more accurate,
Yeah.
and more contextually aware.
Right.
They're really breaking down these language barriers and making global communication much smoother.
It's like having a conversation with someone from another country
Yeah.
without any awkward misunderstandings. Yeah. That's amazing.
Exactly.
And speaking of conversations, LLMs are also powering, this new generation of chatbots, right?
Oh, yeah.
Are they finally getting rid of those, I don't know, clunky robotic interactions?
That traditional chatbots, were often limited by these rigid rule-based systems. LLMs are bringing a whole new level of naturalness and dynamism to chatbot interactions.
Oh, okay.
Yeah.
Making those conversations more engaging
Right.
and human-like.
Yeah,
It's
exactly.
like the difference between talking to a machine and having a real conversation with a friend.
Exactly.
And what about content creation? How are LLMs impacting the way we create and consume content?
Right.
Are they going to replace writers and artists?
So LLMs are definitely becoming, powerful tools for content creators.
Okay.
Assisting with everything from writing marketing copy and generating, creative storylines
Right.
to producing scripts
Yeah.
and even crafting these personalized messages. They're more like, creative partners,
Really?
helping us express ourselves in new and engaging ways.
So it's like having an AI muse
Yeah.
whispering ideas in your ear.
Yeah.
But LLMs aren't just creating content. They're also getting better at analyzing
Right.
and understanding text, right?
Right.
Are they, like, becoming expert readers?
Absolutely. LLMs excel at tasks like natural language inference,
Okay.
where they figure out the logical relationships between sentences
Yeah.
and text classification, where
Right.
they categorize text into these predefined groups.
So they're not just generating text.
Right.
They're dissecting it,
Yeah.
understanding the nuances,
Right. Yeah.
extracting valuable insights.
Yeah.
That's incredibly powerful. What kind of, like, real-world applications are we seeing with this level of understanding?
So these capabilities are being used in areas like sentiment analysis, figuring out, how people feel about something based on their writing,
Right.
legal document review,
Okay.
and even medical diagnosis,
Wow.
where LLMs can help experts make more informed decisions.
It's inspiring to see LLMs being used to tackle real-world challenges in so many different fields.
Mm-hmm.
But we can't forget about the rise of multimodal LLMs,
Right.
the ones that can handle more than just text.
Right.
What's happening in that space? What kind of exciting applications are we seeing there?
Yeah, multimodal LLMs, it's like, opening a door to a whole new world.
Right.
Their ability to process and generate content across text, images, audio, video
It's crazy.
is creating possibilities we could
Yeah.
only dream of before.
It's like we're stepping into this multimedia universe
Yeah.
where AI can understand and interact with information in all its forms.
Yeah.
What kind of amazing things can we expect from these multimodal LLMs?
So imagine AI systems that can create captivating stories from images, personalized educational experiences that combine, text and visuals, or even assist doctors in diagnosing medical conditions by, analyzing medical scans and patient records.
Those applications sound absolutely incredible. It feels like we're on the verge of a major breakthrough in AI.
Yeah.
Where machines can understand and interact with the world in ways that we never thought possible. Where do we go from here? What's next for LLMs?
So with the speed of innovation in this field,
Right.
the future of LLMs is just incredibly exciting. New architectures are being developed. Training techniques are becoming more efficient, and applications are popping up in every imaginable domain.
It's an exhilarating time to be following the world of LLMs. It's like we're riding the wave of a technological revolution with AI playing a bigger and bigger role in our lives.
Absolutely.
But with all this progress, it's important to keep in mind that LLMs are still just tools.
Right.
They're incredibly powerful tools.
Yes.
But tools nonetheless.
Yeah.
What are your thoughts on that?
Yeah, you're absolutely right. As we continue to develop and refine these, powerful AI systems, we have a responsibility to make sure that they're, used ethically and for the benefit of society. It's up to us to guide their development and ensure they're used for good.
We've covered a ton of ground in this deep dive. It's been a wild ride from the nuts and bolts of transformers to the just mind-blowing capabilities of multimodal LLMs.
Yeah, it really highlights the incredible pace of innovation in AI.
Yeah.
New models, training techniques, applications.
That's crazy.
Constantly popping up, pushing the boundaries of what we thought was even possible.
Yeah, it's definitely an exciting time to be following the world of LLMs. But before we wrap up, let's take a step back and look at the big picture.
Okay.
What are the key takeaways from our journey into this amazing world of AI?
So I think one of the biggest takeaways is really the power of scale. We've seen how increasing model size and data volume has led to these huge leaps in LLM capabilities. They're getting smarter and more capable with every gigabyte of data they consume.
It's like they're on a constant learning spree.
Yeah.
But it's not just about stuffing them with information, right?
Right.
Data quality and efficient training techniques are crucial too.
Absolutely. Carefully curating the data and fine-tuning that training process is essential for creating LLMs that are both powerful and efficient.
Right.
It's not just about quantity, it's about quality and strategy.
And we can't forget about fine-tuning, those techniques that transform these, general purpose models into these specialized tools for specific tasks. It's like giving them a set of skills tailored for a particular job.
Exactly. Techniques like, SFT and RLHF
Yeah.
allow us to mold these LLMs into, experts in various domains,
Right.
whether it's summarizing, complex research papers or engaging in natural human-like conversations.
Exactly. And as these models get more powerful, we have to keep up with the practical challenges of actually using them.
Yeah.
Speeding up those response times,
Right.
making them more accessible is crucial for real-world applications.
Right. That's where those, clever optimization techniques come in. Quantization, distillation, speculative decoding.
Right.
They're all helping to make LLMs more practical and readily available for everyone.
It's fantastic to see these advancements making LLMs more powerful, more efficient, and more accessible.
Yeah.
But amidst all this excitement, it's important to remember that LLMs are tools.
Right.
And like any powerful tool, they need to be used responsibly.
You're right. We have a responsibility to make sure that these incredible AI systems are used ethically and
Right.
for the benefit of society.
Yeah.
It's up to us to guide their development and ensure they're used for good.
Absolutely. Well, we've explored the inner workings of transformers, traced the evolution of LLMs, and even glimpsed into the future of multimodal AI. It's been an incredible journey.
It really has. It's been a pleasure sharing these insights with you and our listeners.
Yeah.
The world of LLMs is constantly evolving, so I encourage everyone to stay curious, keep exploring, and let's continue to shape the future of this transformative technology together.
And that wraps up another episode of the Deep Dive. Until next time, keep learning, keep questioning, and keep diving deep into the world of knowledge.